You recall from a while back, I hope, that we used systems of two equations and two unknowns to solve some application problems. And in those cases, there were two things that we didn't know. And what we did was to represent each of them using a variable. Then we wrote a system of two equations with those variables to solve the problem. Now we're next going to consider using systems of three equations to solve some application problems. And in these cases, there will be three things we don't know. We'll need to represent each of them using a variable. Then we'll need to write a system of three equations using those variables to solve the problem. So our first example is the following. We're told that a department store has three kinds of perfume: cheap, better, and best. It has 10 more bottles of cheap than better and 3 fewer bottles of best than better. Each bottle of cheap perfume costs $8, and each bottle of the better perfume costs $15, and each bottle of the best perfume costs $32. And we're told the total value of all the perfume is $589, and we're asked to find how many bottles of each there are. So our next step will be to organize the information into what we know and what we don't know. So under the known column, we can list the following: that there are 10 more bottles of cheap perfume than better, 3 fewer bottles of best than better, that each cheap bottle cost $8, each better bottle costs $15, each best bottle costs $32, and the total value of all the bottles is $589. So what it is we don't know that we'd like to find out will be the number of bottles of cheap perfume, the number of bottles of better perfume, and the number of bottles of best perfume. So what we'll do next is to represent each of the unknown items using a variable. Now I've chosen to let C be the number of bottles of cheap perfume, M the number of bottles of better perfume, and B the number of bottles of best perfume. And I've chosen M to be the number of bottles of the better perfume because I'm thinking of it as being the medium priced perfume. It's clear, I'm sure, that we can't use B to represent both better and best, so we have to introduce some other variable there to distinguish the two. Now just also a reminder, it's important to be very specific when you define variables in an application problem. It would not be complete enough to say, for example, let C be the cheap perfume, because it's not clear from that whether you're referring to quantity or price or something else. So now we next need to write a system of three equations involving these three variables. And what we'll do is go back to the known information to give us some help here. Now we're told that there are 10 more bottles of cheap perfume than better perfumes. That will lead to the first equation, that C is equal to 10 plus M. And we're told that there are 3 fewer bottles of the best perfume than the better perfume, which will lead to the equation M is equal to 3 plus B. And we're told that the total value of all the perfume is $589. So it should make sense then that if each bottle of cheap perfume costs $8, then 8 times C represents the total value of the cheap perfume. And each bottle of the better perfume costs $15, so 15 times M would give us the total value of the better perfume. And each bottle of the best perfume costs $32, so 32 times B then would be the total value of the best perfume. So altogether then, that will equal $589. Now as you look at the system of equations, I'm hopeful that you're seeing that substitution probably will be the best way to go here. So if you look at the first equation, you see that C is represented already in terms of M. So what I'm going to do now is to solve the second equation for B in terms of M. Then I'm going to take each of those expressions and substitute them down into the third equation. So in the first term, I've replaced C with 10 plus M. And in the third term, I've replaced B with M minus 3. So what we'll do next is multiply out combined terms and then solve this equation for M. So continuing then, we can see that our next step will be 80 plus 8m plus 15m plus 32m minus 96 is equal to 589. And combining the m terms, we get 55m. And the constant terms will then produce minus 16 equals 589. Then adding 16 to each member, we get 605. And dividing by 55, we see that m then is equal to 11. So now we'll go back to the equations we created above to find the values for c and b. So in the equation c equals 10 plus m, we're going to replace the m with 11. So we can see that c then will turn out to be equal to 21. And in the equation b is equal to m minus 3, we'll replace the m with 11, and we'll see that b then is equal to 8. So to finish up then, what we'll do is write a sentence answering the question posed by the problem. So we can state then that there are 21 bottles of the cheap perfume, 11 bottles of the better perfume, and 8 bottles of the best perfume. And so let's go through the check. The first equation in our system was c being equal to 10 plus m. So if we replace c with 21 and m with 11, we can see that we'll get a true statement that 21 is indeed equal to 21. And the second equation in our system was m is equal to 3 plus b. So if we replace m with 11 and b with 8, we can see that we also get a true statement that 11 is equal to 11. Then the third equation in our system was 8c plus 15m plus 32b is equal to 589. So replacing the c with 21, the m with 11, and the b with 8, we then get 168 plus 165 plus 256, and that total on the left-hand side then is indeed 589, so those values check in that equation. So we're all happy that everything works out.